Most spiders are built for stealth. They hide in shadows under rocks and corners. Their survival strategy is simple: stay hidden, do not draw attention, and ambush prey. Males find females, mate quickly, and leave before becoming food. No courtship, no performance, just efficiency. That's how spiders work. Except for peacock spiders. Peacock spiders are 5 millimeters long, smaller than your fingernail. Instead of hiding, they perform. The males have rainbow-colored flaps they raise like a peacock's tail, electric blues, vivid reds, oranges, and they dance, an 8-legged choreographed routine with vibrations and leg waves for minutes. If the male messes up, the female kills him. And those colors? They should not physically exist. They are not made from pigment. They are made from nanostructures more precise than anything humans can engineer at that scale. This is what happens when evolution abandons every rule and goes completely insane. Most animals produce color through pigment. Pigment molecules absorb certain wavelengths of light and reflect others. If something looks red, it is because red wavelengths are bouncing back into your eyes while other colors are being absorbed. This is how most of nature works. Flowers, birds, insects, mammals. Pigment-based color. Peacock spiders do not use pigment for their rainbow patterns at all. Instead, they use structural color. Structural color works through physics, not chemistry. Here is how it works. The surface of the peacock spider's flaps is covered in microscopic structures. We are talking nanoscale. These structures are arranged in incredibly precise patterns, like a biological diffraction grating. When light hits them, it does not get absorbed, it gets bent. The structures are so small and so precisely spaced that they interfere with light waves themselves. Certain wavelengths reinforce each other, others cancel out. The result is color, pure, vivid color created entirely by the way light bends and reflects off these nano-engineered surfaces. It is the same principle behind butterfly wings, soap bubbles, and oil slicks. But peacock spiders are doing it at a scale that should be impossible. Here is the scale problem. These structures are around 100 to 200 nanometers. That is 1,000th the width of a human hair. The spider itself is 5 millimeters long. Its brain is the size of a poppy seed. And yet somehow, evolution engineered microscopic structures with tolerances measured in billionths of a meter on a creature that has no concept of engineering, no blueprint, no plan. Just random genetic mutations that happen to produce the right proteins in the right configuration to bend light at the right angle. One mistake in that structure, one misaligned nanometer, and the color changes or disappears entirely. But peacock spiders get it right, every time, across millions of individuals, for millions of years. And because these are structural colors, not pigment, they change depending on the angle you view them from. Move the spider and the colors shift. Blues become purples. Reds become oranges. It is iridescent, a living hologram. This should not be possible, but it exists on a spider smaller than a tic tac. Now let's talk about what the spider does with those colors. Male peacock spiders need to mate, but they have a problem. Females are larger and they are predators. They will kill and eat a male if they mistake him for prey. So the male needs to send a very clear signal. A signal that says, I am not food. I am a potential mate. Please do not eat me. His solution is simple. He dances. Dance. Here is what happens. The male spots a female. He approaches, but not too close. Then he raises his colorful flaps, lifting them up like a peacock fanning its tail, while simultaneously moving side to side in a shimmy and waving his legs in specific patterns, all 8 legs doing different things at the same time. This is not random movement. It is choreographed. Each species has its own signature dance. Some add spins. Some take a zigzag approach. Some wave their legs in sequence like a stadium wave. This can go on for minutes. The male circles the female, performing continuously, getting incrementally closer with each loop. If the female is interested, she stays still and watches. If she is not interested, she either walks away or attacks. Females are picky. They have to be. They are investing time and energy into producing offspring. They need to choose a mate with good genes. The way they evaluate genetic quality is through the dance. A healthy male can dance longer. A genetically fit male can coordinate 8 legs perfectly. A male with good vision can navigate while performing. The dance is a fitness test, and only males who pass get to reproduce. Over millions of years, this created a feedback loop. Females preferred males with better dances. Those males reproduced more. Males had to evolve even more elaborate displays to stand out. There is no upper limit to this process, not until physics itself says stop. In the case of structural color, it did. You cannot get more precise than nanometer scale engineering. But why did evolution allow this to happen in the first place? There are 2 types of selection pressure in evolution: natural selection and sexual selection. Natural selection is about survival. Traits that help you live longer get passed on. That's the one everyone knows. Sexual selection is different. Sexual selection is about reproduction. Traits that help you attract mates get passed on, even if those traits are actively bad for survival. The classic example is the peacock. A male peacock's tail is massive, heavy, and brightly colored. It makes him slower and more visible to predators. It is a terrible survival trait, but females prefer it. So males with bigger, brighter tails reproduce more, and the trait persists. The tail is so costly that only a truly healthy, genetically fit male can afford to have one. It is an honest signal of quality, and sexual selection rewards honest signals even when they are survival liabilities. Peacock spiders are the same principle, miniaturized. The colors take energy to produce. The flaps make the male more visible to predators. The dance requires perfect coordination and stamina. All of this is costly, but it works. Those males reproduce, and the cycle continues. This is runaway sexual selection. There is a feedback loop. Preferences become more extreme. Displays become more elaborate, generation after generation, until you hit a physical limit. For peacock spiders, that limit is the wavelength of light itself. You cannot make structures smaller than the light you are trying to manipulate. They have reached peak color, maximum iridescence, the upper bound of what physics allows. And the result is a spider that looks like it was designed by someone on hallucinogens. Is this efficient? No. Is this practical? Absolutely not. Is this optimal for survival? Definitely not. Male peacock spiders probably have shorter lifespans than they would if they were drab and invisible. But does it get their genes into the next generation? Absolutely. And that is all evolution cares about. Not efficiency, not logic, just reproduction. And there are more things about peacock spiders because they keep getting weirder. There are more than 80 species, and each one has completely different color patterns. Some look like they were painted by abstract artists. Males will dance at almost anything. They will dance at other males, at dead females, even at fake spiders made by researchers. If it is roughly spider-shaped and the right size, a male will try courting it. Females, on the other hand, are brutal. They will sometimes sit and watch an entire dance performance, let the male exhaust himself, and then simply walk away, rejecting him. Hours of effort wasted, just like in real life. This is the peacock spider. This is what evolution looks like when sexual selection goes completely off the rails. There is no logic here, no efficiency, just an endless feedback loop between what females want and what males become. The result is a creature that defies every assumption about what a spider should be.